an identity function f naught g is from y to y, that is f naught g of y will results to y only. 5, 4 and 7, 4, that is 5 and 7 have same images. If they have different images, we can say it is 1, 1. Now how g of function is defined? It is defined in the form of root y minus 6 minus 3 divided by 2. Hello everyone, a warm welcome to one and all. This is Yashati ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So we are in the chapter Relations and Function. In today's session, we are going to learn about a very important concept called invertible function. For your examination, very important, it's a 5 marks question to show that the given function inverse exists and such that writes its inverse. So before going to inverse function, let's study what is identity function. So identity function you have already learnt in the previous year, that is under some special functions. An identity function is a function which gives the same value as inputted, that is f of x is equal to x. So if you take f of 3, then it is 3. If you take f of root 2, then it is root 2. If you put f of 0, then the value is equal to 0. So whatever the value you input, you will get the same result. So therefore, it's a function from the set of real numbers to set of real numbers, that is both domain and range will be the set of real numbers. Now, we have learned the compositions of functions also. So here, let us see the identity function of g naught f and f naught g. So what is this identity function of the composition function? Suppose if f is a function from a to b or g is a function from b to a. So let me take two domains here. So this is set a and set b. So if f is a function from a to b or g is a function from b to a. So or you can take this one as x and this one as y. So if f is a function from x to y, then g is a function from y to x. Then g naught f is a function from x to x itself, such that the identity function g naught f is equal to ix. So that is, if you take g naught f of x, the value will be equal to x always. Similarly, an identity function f naught g is from y to y, that is f naught g of y will results to y only. Thus, it is called as identity function in x and this is called as identity function in y. So, whenever the composition of a function results in terms of identity function, so the value g naught f of x is equal to x and f naught g of y is equal to y. So, why these concepts are necessary? Because an invertible function is said to exist such that if f is a function from a to b, then there must exist a function from b to a, so that g naught f and f naught g are identity function. So that is, the function g is called the inverse of f and it is denoted by f inverse, which is nothing but g. So if f is a function from a to b, g is a function from b to a, then we say f inverse exists, which is nothing but g, only when the composition function g naught f and f naught g becomes identity functions. Also note that here, if f is a function from a to b, then there exists a function from b to a, such that g naught f and f naught g are identity function. What does this is? It means the function f must be 1, 1 and on 2. That is, the function is bijective. So another definition for an invertible function is that the invertible function or f inverse exists only when f is both 1, 1 and on 2. That is, if f is bijective, then we say f is invertible. Thus, we can verify whether a function f has invertible g through two conditions. One is that we should show f is 1, 1 and on 2, or we should verify g naught f and f naught g as identity function. So thus, f is invertible if f is only a bijective function, or we can say f is invertible such that there exists a function g where g naught f and f naught g are identity function. Now let us take few functions to verify whether the inverse of a function exists or not. So here Let S is a set 1, 2, 3. Determine whether the function from S to S is defined as below. Have inverse. Find F inverse if exist. Suppose here you have a domain that is 1, 2, 3 and 1, 2, 3. So this is both are S. F is a function from S to S. Now 1 is related to 1, 2 is related to 2, 3 is related to 3. Clearly this is a 1-1 function because all the elements have different elements in the codomain set, and also for all the elements in codomain you have one image in the domain. So therefore this is both 1-1 and onto, which means F is bijective. So therefore we can write F is 1-1 and onto. So therefore F inverse exists. Now we have to write if F inverse exists. So F inverse is also, so write 1, 1, 2, 2 and 3, 3. So F inverse means back from S to 1. For 1 it is 1, for 2 it is 2, for 3 it is 3. Next one, F is equal to 1, 2, 2, 1, 3, 1. So we are defining function set S 1, 2, 3, 2 S 1, 2, 3. So according to this, 1 is related to 2, 2 is related to 1, 3 is related to 1. This is not 1-1 function, not onto also, because we don't find any element which is related to 3. Also here 2 and 3 have same images. To say it is 1-1, both should have different. So here we can say F is not 1-1. If it is not 1-1, then it is not bijective. If it is not bijective, then F inverse does not exist. Let's see the next question. State with reason whether the following functions have inverse. So here F is a mapping from 1, 2, 3, 4 to 10. So you can clearly observe for all the images 1, 2, 3, 4. For all the domain elements 1, 2, 3, 4, the image is 10. That means clearly we can observe here F is not 1-1. So therefore what we can write, F inverse does not exist. So for all the elements in the domain, you should have a different images in the codomain, but here they have the same image. So therefore it is not 1-1. So therefore F inverse does not exist. Next one, 5, 6, 7, 8, 1, 2, 3, 4. G is equal to 5, 4, 6, 3, 7, 4, 8, 2. Clearly you can observe this 5, 4 and 7, 4. That is 5 and 7 have same images. If they have different images, we can say it is 1-1. But they have same images. So therefore here also F is not 1-1. So therefore F inverse does not exist. Thus, if F inverse exists, it should satisfy the condition of 1-1 and onto. That is, F is bijective, then F is invertible. Now, let's move on to the important type of question. These are all the questions they ask you for 5 marks, which are very important. We have to show that the given function is invertible and hence find their inverse. I already said to you, by showing F is 1-1 and onto also, we can show that the invertible exists, or by the method of composition of function, that is showing G0 F and F0 G are identity function, we can write the inverse of a function. So, here given F is a function from R to R. So, F of X is equal to 4x plus 3. So this means here I can write y is equal to 4x plus 3. If y is equal to 4x plus 3, then what is x? So find x. So here we have 4x is equal to y minus 3. So I can write x is equal to y minus 3 by 4. So this one I can take it as, so let f of x is equal to 4x plus 3. If f of x I take it as y, then it is equal to 4x plus 3. Now find the value for x. So then we can write g of y, because we have to show that if f is invertible, then there exists a function g, which is g of y. G of y can be written as y minus 3 divided by 4. This implies x is equal to y minus 3 divided by 4. Remember, the function is given in the form of f of x, which is nothing but y. We have to convert it in the form of x, which is nothing but g of y. So g of y, we get it as y minus 3 by 4. What is y minus 3 by 4? It is x. Now let's take g naught f of x. G naught f of x should get x only. Let us verify it. G of f of x. Since we know how to write the composition of a function. What is f of x? So f of x is nothing but 4x plus 3. Write it as 4x plus 3. Next, how we write the function g of y? G of y is written as y minus 3 by 4. So in the place of y, we are replacing it with 4x plus 3. So we can write it as 4x plus 3 minus 3 divided by 4. Plus 3 minus 3 cancels. Next it is 4x by 4. 4 and 4 get cancelled. So we got x. So we are getting g naught f of x is equal to x. Now let's verify for f naught g of y. F naught g of y means f of g of y. So what is g of y? G of y is nothing but y minus 3 divided by 4. So this can be written as f of y minus 3 divided by 4. How is the function f defined? F of x is nothing but 4x plus 3. So in the place of x, replace it by y minus 3 by 4. So we get 4 into y minus 3 by 4 plus 3. So 4 get cancelled. We get y minus 3 plus 3 plus 3 minus 3 get cancelled. So we got y. So we got f naught g of y is equal to y. That means they are identity function. Whatever the value you input, the result is same. So thus g naught f and f naught g are identity functions. Hence, f inverse exists. So, therefore, G is inverse of f. So, thus, what is G? F inverse of x we can write. F inverse of x is nothing but here. So, this G is the inverse of f. So, G is the inverse of f. How is G is defined? Y minus 3 by 4. Just replace this with x. So, therefore, f inverse of x is x minus 3 by 4. So, this is the inverse of f. So, thus, to prove the given function is invertible, you have to take the given function in the form of f of x. Then, find the value of x, which is nothing but g of y. Find the composition of g naught f of x, where you should get the value of x. Find f naught g of y, you should get the value of y. Once this is satisfied, that implies they are identity function. When they are identity function, it means f inverse exists. F inverse exists means we can say G is the inverse of f. How G is defined? In the form of y minus 3 by 4. So, therefore, in the place of G, we can write f inverse of x. In the place of y minus 3 by 4, we can just write x minus 3 by 4. So, you are just replacing the variable y with respect to x. So, this is the inverse of the given function. Next one, consider f from r plus to 4 comma infinity given by f of x is equal to x square plus 4. Show that f is invertible with the inverse f inverse of f given by f inverse of y is equal to root y minus 4, where r plus is the set of all non-negative real numbers. So, r plus denote the set of all non-negative real numbers. That means the function is only defined for the set of all non-negative real numbers. Now, let's see here. We have f of x is equal to x square plus 4. Let f of x is equal to x square plus 4. This means f of x can be written as y is equal to x square plus 4. Then how to find the value of x here? So we can write x square is equal to y minus 4 or x is equal to root of y minus 4. So then here I can write g of y in the form of root of y minus 4. So that means x is equal to root of y minus 4. So let me take the composition g naught f of x. So which is g of f of x. So how is f of x defined? In the form of x square plus 4. How is g of y defined? And root of y minus 1. So in the place of y, you are substituting x square plus 4. So this is x square plus 4 minus 4 under the square root. Plus 4 minus 4 get cancels. We have square root of x square cancels. So the answer is x. Since it is defined only under the positive real number, we can't write here plus or minus x. It is only positive real number. So therefore, we have to write plus x. So we got g naught f of x is equal to x. Now let's check for f naught g of y. F of g of y. So what is g of y? It is root of y minus 4. So root of y minus 4. If it is f of x, then it has written in the form of x square plus 4. In the place of x, now we are replacing it with root y minus 4. So it is root y minus 4 whole square plus 4. Again square and square root get cancels. Y minus 4 plus 4 plus 4 minus 4 get cancels. Hence the answer is y. So we got f naught g of y is equal to y. So clearly we can say thus g naught f and f naught g are identity functions. Identity function. So hence f inverse exists. So therefore g is inverse of f. So how is g is defined now? G is defined in the form of root y minus 4. Thus we can just simply write, therefore f inverse of y is equal to root minus 4. So you can also replace y by x, which is one and the same. F inverse of y is root y minus 4 or f inverse of x is equal to root x minus 4. So this is the inverse of the given function. Next one. Let f from n to r be a function defined as f of x is equal to 4x square plus 12x plus 15. Show that f from n to s, where s is the range of f, is invertible. Find the inverse of f. So here the function is defined from the set of natural number to real number, and another function is defined from natural number to the range of the first function. So we have to show that it is invertible and we have to find the inverse of f. So here f of x is given in the form of 4x square plus 12x plus 15. We'll just simplify this and factorize it, or by using the completing square method, we can write this as 2x plus 3 whole square plus 6. So we take let. From this we get y is equal to 2x plus 3 whole square plus 6. Now let us find out x now. So we have here y is equal to 2x plus 3 whole square plus 6. So here we get y minus 6 is equal to 2x plus 3 whole square. Then it becomes root of y minus 6 is equal to 2x plus 3. Then I can write this as root of y minus 6 plus 3 when it comes minus 3. And here it is 2x. So I can write x is equal to root y minus 6 minus 3 whole divided by 2. So this is the function x. So thus we can write then g of y is equal to root of y minus 6 minus 3 divided by 2. So that is x is equal to root of y minus 6 minus 3 divided by 2. Now we have both f and g function. Let's see G naught f of x. So what is G naught f of x? G of f of x. So G, what is f of x we have taken? We have taken it as 2x plus 3 whole square plus 6. Now how G of function is defined? It is defined in the form of root y minus 6 minus 3 divided by 2. So that is 2x plus 3 whole square plus 6 minus 6. In the place of y, you are substituting this term minus 3 divided by 2. So plus 6 minus 6 cancels here. So square and square root also cancels. So then we are left with 2x plus 3 minus 3 divided by 2. Again plus 3 minus 3 cancel. 2x by 2 means 2 and 2 get cancels. We got G naught f is equal to x. Now let's verify f naught g of y. So f naught g of y means f of g of y we have taken. It is root y minus 6 minus 3 divided by 2. So root y minus 6 minus 3 divided by 2. So how f is defined? F is defined in the form of 2x plus 3 whole square plus 6. So in the place of x, you have to replace this. So which is 2x plus 3 whole square plus 6. Now here 2 and 2 get cancels here. We have root y minus 6 minus 3 plus 3 whole square plus 6. Minus 3 plus 3 cancels. Square root and square cancels. Y minus 6 plus 6 we have. Minus 6 plus 6 cancels. So y we got. So we got G naught f of x as x. F naught g of y as y. So therefore G naught f and f naught g are identity function. So therefore or hence f inverse exists. This implies G is inverse of f. So what is G? How is G defined? G is defined as root y minus 3. G is defined as root y minus 6 minus 3 by 2. So therefore f inverse of x can be written as root of, so just replace y minus 6 by x minus 6, x minus 6 minus 3 divided by 2. So this is the inverse of the given function. So all these question carries 5 marks, very important for your examination. So there will be one question from invertible. Next question, show that f from minus 1 to 1 to r given by f of x is equal to x by x plus 2 is 1, 1. Find the inverse of the function from minus 1 to 1 to range of f. So first let us show that it is 1, 1 function. Then let us find the invertible function. So to show that, we have to take f of x1 is equal to f of x2. If this condition satisfies, then we can say it is 1, 1 function. So f of x1 means we have x1 divided by x1 plus 2, x2 divided by x2 plus 2. So we have x1 x2 plus 2x1, x1 x2 plus 2x2. So cancels, we got 2x1 is equal to 2x2. Again 2 get cancels, we got x1 is equal to x2. Hence we can say f is 1, 1. Now we have to find the inverse of the function. So we have f of x is equal to x divided by x plus 2. So that means what? We have y is equal to x divided by x plus 2. Let's find the value of x. Then it is xy plus 2y is equal to x. So then we can take x as a common factor. We get y minus 1 and here plus 2y is equal to 0. So or I can write x is equal to 2y divided by 1 minus y. So let me take, let f of x is equal to this. Then I can get g of y. Then g of y, I will get it as 2y divided by 1 minus y. Let us verify G naught f of x. So G naught f of x is G of f of x. So which is G into x divided by x plus 2. Now here it becomes in the form of G of y, just replace y by x divided by x plus 2. 2 into x divided by x plus 2 divided by 1 minus x divided by x plus 2. So this is 2x divided by x plus 2, and here we get x plus 2 minus x divided by x plus 2. X plus 2 cancels, plus x minus x cancel, 2 and 2 get cancelled, so the answer is x. Next we will verify f naught g of y, which is nothing but f of g of y. So what is g of y? G of y is 2y divided by 1 minus y. 2y divided by 1 minus y. How is f defined? In the form of x divided by x plus 2. So I can write this as 2y by 1 minus y. X plus 2 means 2y 1 minus y plus 2. So I can write this as 2y divided by 1 minus y whole divided by 2y plus 2 minus 2y divided by 1 minus y. 1 minus y cancels, 2y minus 2y cancels, plus 2 cancels. So the answer is 5. So clearly you can observe G naught f of x is x, f naught g of y is y. So what we can conclude? So we can say that G naught f and f naught g are identity functions. Identity functions. So if they are identity function, obviously we can say f inverse exists, that is G is inverse of f. So therefore f inverse of x can be written as, how is G defined? G is defined in the form of 2y by 1 minus y. Just replace with x, then it is 2x divided by 1 minus x. So this is the inverse of the given function. Thus, to verify the inverse of a given function, just show that G naught f and f naught g are identity function. Then write G in the form of x. That itself is the inverse of the given function. So as I said, the concept of invertible function is very important, which is asked for 5 marks in your examination. We'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.